Computer Science 150, Introduction to Computer Science. Today we're going to talk about abstract data types and separate compilation, why this idea is so important for code reuse and organizing our code for larger projects. So far we've seen the theory of classes as natural behavior systems and why they're good for modeling real-world phenomena. We've also seen how to define the key components of the class and get them to work. We've looked at attributes and methods that are associated with classes. And in terms of the methods, we've written a few key ones: the accessors that get the information, the mutators that set the information, and the constructors that instantiate a new instance of the object. We've also seen how to use classes with the member access operator, and that was probably the fun lab of the session. But it's important to know how to do all these things, and we talked about wearing different hats. So this leads us to an idea of data abstraction. And abstraction is a powerful concept in computer science. It means avoiding paying too much attention to all the details. If you drill down deep enough, it gets very, very detailed, and oftentimes we don't want to think at that detailed level. So abstraction in this context is separating the design details from the usage. So basically, how do we actually use this class versus how do we design it? It's the same thing. In some ways you use CN and COut without thinking about the code underlying CN and COut. And that's okay. Abstraction is that very idea that you don't need to know all the details in order to look at things from a higher level. So an abstract data type is a data type that separates the logical properties from its implementation details. So three things that are associated with the ADT: the name, the domain, which are the set of values, and then the set of operations on the data. So those are the three things that are also associated with the class. So we'll use this idea with our classes. So we're going to separate the how from the what. The class interface is kind of the contract. This is the how. These are the public member function declarations, and basically they tell us the what. Sorry, it's not the how, it's the what. Basically, these are the things that the class does. And you've seen this when you use the dot operator, you get a list of different things that the class can do, whether that's the string class or something you've defined yourself. The implementation is where the rubber meets the road in terms of details. And these are the private member variable declarations, member functions that are also private, and how those functions work. This is the how. And a lot of times if we're just using the class, we don't need to know the how. So if you're designing your class, you may want to separate out the what, how people are going to use it, from the implementation, the how it actually gets done. So we can do this by making separate files. One for the class definition, that's the interface file. This is typically a .h file. The implementation file, which is the same name as the header file, but with .cpp. And then the application code that typically goes in our main program, and that's the actual use. So we separate the what from the how from the actual use into separate files. Naming conventions: if the class is named XXX, then the header file is XXX.h and the implementation is XXX.cpp. We need a pound include directive in both the application file and the implementation file to know that we're using that particular header file. And we'll do that as pound include quotes, XXX.h. end quote. And the quotes are different than the arrows that we use with our predefined library. So that's one area where we need to be careful syntactically. So some of the advantages to separate files: again, they hide details. Sometimes we don't want to know all the information about how something gets done. And once our implementation file is test and bulletproof, we don't need to compile it again. And we can also make that reusable code and put it into a class library. So, if we have another application that needs a student class, we can just pound include our student class again. Rather than copying and pasting the code and potentially subjecting it to errors. One thing is you want to prevent multiple definitions, and good integrated development environments take care of a lot of this for you nowadays. But if you're doing this inside the header file, you would say, if not defined, name of the class _h, go ahead and define it, pound define in this case, XXX_H, give the class definition, and then you do a pound end if. These are preprocessor directives. So it says don't compile this, more than once. If you've already seen it, just go ahead and ignore it. The header file can't be compiled just in and of itself. You basically need to develop and test it inside of an application program first before you separate it out. So basically put it into a single file of main and test it out, make sure it works the exact way that you want it, and then split the file into 3 parts. And you may need to make some minor adjustments and to test it again, but most of the time for 150 level stuff, this will work exceedingly well. We talked about the inline accessors and mutators. Basically, you can write these right next to where you declare them. And, this is a good way of doing things because it saves a lot of space. And that's it for the abstract data types. This is an important idea. So we'll be using this a bit more from now on out, particularly when we have multiple classes involved. Thanks so much for watching.